Okay, so in this video, what I'm going to look at is another linear programming problem. That means that we're looking for the maximum or minimum. In this case, I'm going to find both, actually, so that you kind of see an example of both. For the feasible region given by some inequalities. So you'll notice here on the last problem I did, they gave us a graph of the feasible region, and it was shaded, right? And we just took the vertices of that shaded region and plugged those into the function to find the maximum, okay? What we're going to be doing today, or in this video, is we're going to look at what if they don't graph the feasible region for you, okay? What do you have to do then? Well, if they give you just a list of inequalities, okay, what you're going to want to do is you're going to want to graph your feasible region, okay? So essentially the process is the same as the last problem. It's just I want to graph the feasible region and find the vertices so that I can plug them in and find the maximum or minimum, okay? So the function I'm going to be maximizing and minimizing in this case is this Q. It's 7x minus 2y plus 3. That's the thing we want to maximize. And then our feasible region is given by these inequalities. Okay? So to actually figure out what the feasible region looks like, I would recommend that we actually graph it out. So what I'm going to do is I'm going to convert these to like y, to get y alone on one side so that I can see what these lines are going to look like. So to get y alone, I'm going to subtract x from both sides here. We get y is less than or equal to negative x plus 6, just adding negative x to both sides. This one, to get y alone, I'm just going to add 3x to both sides. So here we get y is greater than or equal to positive 3x minus 2. Okay? And then these last ones are kind of already solved. These are equations of lines, right? So x is greater than or equal to 0, and then y is greater than or equal to 0. Or, excuse me, sorry, they're not equations of lines, but if you replace them with equal signs, they would be equations of lines, okay? So, we've got, this is our feasible region given by these inequalities. Now what I want to do is I just want to sketch a graph of it, okay? So I'm going to sketch a graph of what this will look like. So negative x plus 6, what is that going to be? We have a y-intercept of 6, so 1, 2, 3, 4, 5, 6 up here. And then we've got a slope of negative 1. So when we go down 1, we go over 1. Okay, down 1, over 1. That's going to be kind of what our line looks like. So this is number 1. Maybe call that number 1. This is number 1. Okay? And I'm going to draw in as well, this is an inequality, right? So I'm going to shade part of my graph here. So I just want to figure out which part should I shade. Well, it's y is less than or equal to negative x plus 6. So y needs to be small. So in other words, you need to be below the line, right? So this part of the line would be shaded, okay? So the downward part, okay? Now, for this other one, 3x minus 2, we've got a y-intercept of -2, and then a slope of +3. So I go up 1, 2, 3, and then over 1. Maybe I should switch colors so that we have different colors. So this is number 2. That's our second equation that we're graphing. And we're saying y needs to be greater than or equal to this, right? So y needs to be bigger, which will mean that you're above the line. So on top of the line is where we're going to be. So it's going to be shaded on that side of the line. I'm just putting in arrows so that we don't get too confused with all the colors swirling around. Okay? So, then the last things we want to do is we want to have x is greater than or equal to 0. So that's going to happen over here, right? And then y is greater than or equal to 0 is going to be over here. So essentially, we're just going to be in this corner, right? That's where x is positive and where y is positive. We're going to be in here. And then we just have to figure out our intersection, okay? Well, where do these shadings overlap with each other? It's going to be, well, it's below this line. This doesn't work because this one is above this line, right? So it's going to be this little shape right here. So that's our feasible region there. Okay? So this is our feasible region that we have going on. And now because we've got this one, this number 1, we're below this line. This one, number 2, we're above this line. We've also got to have x is positive, y is positive, so it's going to be this chunk right in here. That's where all of those work. Okay? So if we look at our graph here, maybe I should expand this a little bit so that we get a really good idea of what's going on. I'm going to draw kind of a fresh version of this shape, okay, of our feasible region. Okay, so we've got this. Whoa, come on. And my art skills are really showing off here. Okay, and then we've got a line coming down like that. We've got a slight inlet here. Okay, and then we've got a line coming up. Intersecting. Okay, so this is our feasible region. It's the stuff on the inside here. And you'll notice the vertices of this feasible region, those are happening at the corners, right? Here's a vertice, here's a vertice, here's a vertice, and there's a vertice. Okay? So we have a total of 1, 2, 3, 4 vertices for this because there are kind of 4 corners here. Okay? You can see that in our original graph too. It's just not really big enough. They're there, here, 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 and so on. Okay, so those are our vertices. So I just need to figure out what these points are so that I can plug them in to the function and see which one gives me the biggest and which one gives me the smallest number, okay? So what I'm going to do is we'll look at kind of at our graph here. This point, this vertice is this point, which, where is that at? Well, that's just at 0, 0, okay? And I maybe scroll a little bit so that that looks like an 8. Let's replace that. Oh my goodness. Okay, so that one's at 0, 0. That's not too hard to get. This other one on the top here, okay, where is that going to be at? Well, it was the y-intercept of this line here, the number 1 line. So it was 1, 2, 3, 4, 5, 6 up. So it's at x equals 0, y equals 6. Okay? So that's where that point is. Now, to get, let's do this point. Okay? To get this point, what we're going to need to do is we've got these 2 lines intersecting, right? Number 1 and number 2, those are intersecting to give us that point. So if I want to figure out where that point is, figure out where this point is, what we're going to have to do is figure out where the lines from these 2 inequalities intersect. So in other words, what I'm going to be doing is, to find this one, we're going to be looking at the system of equations, y equals negative x plus 6, that first equation of my line, and then my second equation of my line is y equals 3x minus 2. And maybe scroll a little bit here. Okay, so both of these equations should be satisfied at this point, right? So I just set up a system of equations and solve. Okay, now this one, this system of equations is pretty nice because I have both of them solved for y already. So I'm going to use maybe a substitution here to solve this. So substitution. I already have it solved for y, so I'll plug this y into this equation. So I'll replace y with negative x plus 6 equals 3x minus 2. And then we just solve for x, okay? So we add an x on both sides and then add a 2 on both sides. We get 8 equals 4x, and then divide by 4, we get x equals 2, okay? So we know the x-coordinate of this point is going to be 2. The y-coordinate I can get by plugging it in x into either one of these equations. So let's do the first one. We plug in x equals 2 into here, we get negative 2 plus 6. Negative 2 plus 6 is 4. Okay, so that's a 2, 4. Okay? And then our last vertex here is just going to be this last corner here. That's going to be right here, which is the x-intercept of our number 2 line. Right? So the x-intercept of the number 2. So in other words, I want to figure out, well, for sure y is going to be 0 here because it's on the x-axis. But then I just have to figure out what x is. So I look at my equation of my line. It's 3x minus 2. Okay. So y equals 3x minus 2. That's the line that's coming off here. And so I set y equal to 0 in here. And then we just solve for x. So I add 2 to both sides. We get 2. It's 3x. And then divide by 3. So we get x is 2/3. Okay. So there is our feasible region. Okay. And we've got all the vertices now of this feasible region. Okay. So now the only thing we have to do, The last thing we have to do is we just have to plug in all of these to see where the biggest and the smallest number happen. Okay? So the function I'm maximizing is 7x minus 2y plus 3. So Q equals 7x, and it was 2y plus 3. That was minus 2y. Minus 2y plus 3. So then what I'm going to do with this is I'm just going to take all my vertices, x's and y's, and we'll plug them in to get what q is. So my first vertice was, we'll do 0, 0. We've got 2/3, 0. And then we've got 2 and 4. And then our last vertice was 0 and 6. Okay? So those are all our vertices here. Okay? So now what I do is I just plug in these x's and y's into this equation and see what I get. So when I put in 0 for x and 0 for y, I get 7 times 0. 2 times 0 is just 0. That's going to give us 0. Plus 3 is just 3. Okay? So that's one. Now let's look at when I replace x with 2/3 and y with 0. Okay? So I'm going to get 7 times 2/3, and then this would be 0, right? Because y times 0 is just 0, plus 3. What is that going to be? Let's throw that in the calculator. Yes, I got some new calculators for us to use. They all look like this, so we don't have to borrow the libraries anymore. I'm pretty excited about it. It will be good. And then we're going to plus 3. Okay, so apparently this is about, it's like 7 and 2/3. So 7.66 repeating. That's our value there. Okay? Now I'm going to plug in 2 and 4 in for x and y. So when I plug in 2, I get 14. And then 4, I get minus 8 plus 3. So I think we get 9 here, right? This would be 14 minus 8 is 6 plus 3 is 9. Okay? And then 0 and 6, when we plug that in, for x we get 0 here, y we get negative 12 plus 3. So that's negative 9. Okay? So you can see from this where the maximum and where the minimum are happening. You just look through for the biggest number. Well, it's not 3, it's not 7. It's here, it's 9. So this is the max. And then this one, the smallest, the negative one, this is the min. Okay? So that's your max and your min of this function. Okay? So what were our steps again to do this? We started with our system of inequalities and we graphed the feasible region. We found our vertices of this feasible region, and then we just plug those vertices in to the equation to figure out where is it going to be the biggest and where is it going to be the smallest. Okay? So hopefully that helps. You can go ahead and try it. You have, I think, like 2 homework problems like this, so hopefully this will be helpful for that. Okay?